for the drums.
Hey guys.
Hey, Keith.
Hey, Keith.
Hey, so I've got today the third of my mental models series. This is actually the second mental model. The first episode was just an introduction to the series. And so what I want to do is kind of kick it in and dive a little bit deeper into a handful of slides that I just kind of flashed on the screen with Jonathan when we were talking previously about tidy data. And what I'd like to do today is dig a little bit deeper into this mental model that I think of when I say Tableau prefers tidy data. Yeah. And, the word tidiness, we don't need to go down this rabbit hole, but the more and more I'm a practitioner of what we do for a living, the more tidy is so important, tidiness in general all around. So what do I mean by this thing when I say Tableau prefers tidy data? What I'd like to do is refer to this fellow, Leo Tolstoy, uh, who was a prolific author. He wrote a few books you might have heard of. Uh, Leo Tolstoy, he famously said that all happy families resemble one another. And yet somehow each of the unhappy families are distinctively unhappy in their own unique, special way.
Hmm.
And later I came to find that Leo Tolstoy was a professional on this. I don't know exactly how many children he had. I think he might have had like 9 kids. But to me, this is this really profound thing. And it was also really profound to Hadley Wickham. So this mental model comes about from Hadley Wickham, who massive guru in the data industry, is the author and owner of the Tidyverse packages in R. I went to Hadley Wickham's kind of multi-day workshop, and so I picked this up from him. Hadley just presented to us, he said, like happy families, tidy data sets are all alike. But somehow the untidy, messy data sets are each uniquely messy in their own distinct, special way.
Yeah, there are only a few ways to make it clean, but there's infinitely many ways to make a big mess.
Right? Infinite numbers of ways to make a big mess. But so here to me, the really important thing about this mental model is that we're not necessarily just saying, oh, it's tidy, it's clean. But rather what we're getting at is that as sense makers, what we do for a living is we make meaning from data. And so tidy data is actually a format. It's a structure. And it's a standardized structure such that it facilitates extracting the meaning from the data. So in other words, meaning making from the data is facilitated by the structure of the data because the meaning is baked into the format of the manner in which the data is stored that you're working with. And so what is tidy data then? Tidy data is this standardized format where each unique thing that varies is stored in its own column. And so what that means is every variable in the data has its own column, and each new variable is distinctly identified in a column of data. And each new observation of those variables is stored as a new row, as a new record. And this to me is super crisp and clear, especially when you go to the entomology of things, right? And you look at the word record, each new record. It's a recording, right? It's a recording. It comes from the Silk Road and trade and the invention of the spreadsheet and the abacus, right? Every new thing that varies is a recording of each observation of a new set of variables as they pass through the observation station.
I really like that connection to history of that recording.
Yeah, it's like
Yeah.
that's what a record is. It's a
hmm
recording of observations. And so then um, the observations themselves are stored at the intersection, the cell of the new observation of the things that vary. And so the means by which this makes meaning making of the data much more simple is that we don't necessarily have, which is often the case with messy data, one thing that varies spread across multiple columns. Like oftentimes,
hmm
finance people will pivot an Excel spreadsheet and have a column for each
Hmm.
year,
Yeah.
right? So that's one thing
hmm
that varies, the year, but now it's been spread across multiple columns, right? And it also doesn't mean that we have multiple things that vary in the same column, where there's two or three things that vary separated by a semicolon, and they've all been
hmm
squished into the same column.
Wouldn't that be a case where, where you had part of what I really loved when you introduced me to this idea was this separation of variables, observation, values, and we can talk about those values where we have multiple things like the kinds of ice cream somebody likes or something, and they're separated by semicolons. We've taken one cell and put multiple values in one cell. So if multiple values are in one cell, that's an indication that the data is untidy. Just like if we have we have each column is 1 year and there are multiple years in the data across multiple columns, that's the data being untidy in another way.
Hmm.
In a different way. Yeah. And so if you think
Yep.
about what Tableau is doing with the Tableau query process that we talked about in the
hmm
previous mental model, and that this whole Tableau query process is this iterative visual analytics cycle where the analyst is making meaning of the data, it then becomes rapidly easy to understand why meaning making becomes difficult if in the location where Tableau would expect to have one value, there's many values,
hmm
or if in the location where Tableau expects to have one variable, it's been spread across multiple columns. Tableau is oriented in this Tableau query process to treat data like it was stored in a database. So the structure, the data types, the format, this tidy data format that the data is stored in is kind of what Tableau is expecting when it goes to query a table of data. And so we talked earlier how I had spent an entire, Sunday afternoon working with wide data and like driving myself crazy. And then when either you or Joe told me to pivot it and make it tall, what had Joe had told me to do at that occasion was to make it tidy, right? To
hmm
tidy that stuff up. And so this then is the mental model. And of course, all rules exist to be broken. It's not to say necessarily that we would never want to have a concatenated string of values, that have multiple values squished into a single cell. There could be reasons from a data engineering perspective that we desire to do that in order to, fit the data model that we want. And I know that Jonathan, when you're finished with your grand totals episodes, next you're going to move into analytical data modeling
hmm
and how to build analytical data models. So the mental model here is not necessarily to drop down like a hard and fast rule that says it must be this way. There can be occasions that we want wide data and we want to pivot the years out to a different column or one variable out to different columns.
Hmm.
There can be occasions that we want to take multiple values and squish them into a single cell in order to set the granularity of the logical table we're working with. But nevertheless, as we're kind of scaffolding and building these concepts upon each other, one of the places that I observe that many people that are working in Tableau get lost or stuck is just a disconnection from what is Tableau expecting by default when it connects to a data set, and why is it so difficult to get the answer out? It's because the data that you've put in is not in this tidy format often.
That's something I see pretty regularly with new users is that they've
Hmm.
seen some Tableau demos or Tableau training, and those data sets have been set up to flow well with Tableau. They're tidy, or set up to match the analysis, and then people get to using their real world data with Tableau that isn't so tidy, and then they're trying to drag and drop and things aren't working.
Right, and they think somebody sold them some snake oil because they saw the
Yeah.
demo and it was so easy. You could
Mhm.
just drag and drop, and now here they are with their data set, and they're dragging, and it's hard and it's
Mhm.
difficult.
Yeah.
So Keith, I like the fact that this series and this particular topic in the series goes along with a mental model, because I think a lot of this frustration comes from the fact that, in Excel, if I want years across columns, um, the data is stored in the way that I want to display it in my final chart. So there's no disconnect between what I see and the way that it's stored. But here, we have to store it a little bit differently. And because we can't always see with our eyes the format in which it's stored, it's back off in some database. So we have to sort of imagine a little bit, what is this table structure underneath? We do have to have a mental model. We have to be able to build a picture in our mind when we connect. What does this structure look like? So that with that picture in my mind, I can make pictures in Tableau more flexibly.
Mhm. I'd like to add one piece to that from helping a bunch of Excel users and some people who use R and Python who they start using Tableau and have challenges. And it's that in those tools, that difference of what is a row, what is a column, what's the value in the cell doesn't matter so much. That in Excel, because we're referring to cells, we can build a chart out of any arrangement of a table and get the chart that we want. Whereas in Tableau, that's going to be harder or easier depending on that arrangement, because that piece of Tableau being more based on SQL databases and that arrangement in its initial form.
Totally. And so when you drag and drop a pill onto the canvas, that pill, it represents an entire column in the data set.
Mm-hmm.
And we talked last time, Jonathan, about the Tableau query process. Tableau is doing dozens of things with just that one activity of rearranging the pills on the canvas. And so to Robert's point, when you're working in Excel, you kind of do a thing, you see the result, you do a thing, you see the result, you do a thing, you see the result. It's always in your face. Tableau, in order to accelerate the pace at which we're able to stay in this cycle of visual analytics and stay in that flow state, is doing dozens of things with a single activity. And it's expecting when you drag and drop a pill onto the canvas, it's manipulating an entire column of data, that column of data should represent a set of variables across which each row is an observation. So to me, this is really fascinating because it's kind of fundamental and baked into the manner in which Tableau behaves. And yet it's not actually, and it's so plain and simple once you kind of lay it out like this, right? And yet it's not the type of thing that people often think about. And so this slide, I'm just kind of fitting in here in order to illustrate that tidiness in a data set is not only strictly Hadley-Wickham's definition of variables, observations, and values. Tidiness in a data set also extends much further to all of these other things, like setting your data types correctly, having really good naming conventions, arranging the data set so that you have your hierarchies in place, that your geographic roles are in place, so that your image roles are set correctly, right? So if you're the person who is curating data sets for others to use and consume, including yourself, this concept of tidiness goes so much deeper than just variables, observations, and values, rows, columns, and cells. It extends much deeper, and the whole kind of mental model itself wraps up in order to say that there's this thing that is tidiness that is fundamental to the manner in which Tableau behaves. And if and when you're experiencing some friction with the behavior of Tableau, it could just be that you're feeding it an input that is not conducive to the behavior that you're expecting as an output.
Can I give an example of this?
Yeah.
On this, I was just helping somebody with the other day. Can you go back to we'll show the original slide here with data types is I was helping somebody recently who was trying to map some things in Tableau, and they had a data set with latitude and longitude coordinates of their observations, and um, that was all great. But the thing was, in their Excel file, that latitude and longitude was in one field, so it was like number comma number split by
Oh,
that. And they're like, I can see this in my data. I know where these points are. I know my data is good. It won't map. And it was a case where their data type of that field was a string.
Mm-hmm.
And then they parse that out because Tableau has built in functions like split and things like that. And they end up with latitude and longitude. And then they're like, why can't I map them? Well, they're still strings, and Tableau needs them to be numbers. So there's this kind of multiple steps here to get it to work. So this is a place where this combination of, is your data type what Tableau needs? And to Robert's point earlier about mental models, this is a case where ideally Tableau would be absolutely brilliant and be able to go, this is latitude and longitude. I'm just going to plot it for it. Tableau is a computer. It's not as smart as us humans. And so we have to adapt our mental model to the tool.
yep. And this is really where, when we introduced the mental models series, I gave these two different definitions of data, right? When we asked, what is data?
Mm.
On the one hand, data are these facts and statistics that are collected together for reference and analysis. But on the other hand, there's this other definition, which is they're characters and symbols upon which operations are performed by a computer. And so in your example here, if the latitude and longitude are still of a string data type, the problem is not with the facts and statistics that have been gathered together for reference and analysis. It's just that the characters and symbols are of the incorrect data type, and the operations performed by the computer are breaking.
Exactly.
Okay, so why is this important? Really, it just comes down to speed, right? Like at the end of the day, my Sunday afternoon with the wide data, your person with their latitude and longitude, like you can wrestle with it to make it work. It's really just a question of distance versus displacement, right? If you know the mental model and the structure and the tidy format, you can give as inputs into the task that you're attempting to perform um, the necessary kind of care and attention that will minimize the displacement between where you're trying to go, so that it doesn't turn into such a big, long, hard, difficult task.
So to summarize what you just said, Keith, and a few things that you've said already, to me, what tidy means is that I can find what I need quickly. And when I find it, it's in the condition that I expect it to be in. But I want to be able to find it quickly. And, to go one level deeper about the why here, why is speed important? Well, because when I want to go and get data, I don't want to have to go and poke around, right? I don't want to go and try and figure out where is it, what is it, all of those kinds of things. I want it to be easy to find. And that's what any organizational system does to me. Speed is great, but it's not for the sake of speed. It's for the sake of the person who's trying to find something. Your little path here actually makes me think of something that goes on in our house a lot. We've got a particular key to a padlock that we use a lot. And, that key walks around, and sometimes it's in someone's pocket. Sometimes it's in the back room. Sometimes it's by the phones, And so this little squiggly path that you have is almost like me walking around the house. Where's the key? Where's the key? Who put the key? And if we don't have it in a consistently organized place, it's where did the thing go?
Yep. And to think about Jonathan's observation that Tableau is a set of computer code, that it only knows what to do, that it's been programmed to do. It's programmed to accept the tidy data by default. And so if you can just do that, restructure the data that you're going to give it as an input, then you can drop into this flow state and be in that really kind of blissful cycle of analytics where you're action, insight, action, insight.
Yep. Just giving the tool a little help.
Yep.
so it
Okay.
can
Well,
help
thanks,
us.
guys.
Yeah,
That was great.
yeah,
Really appreciate
thanks.
your time and attention today. And we'll see you next time for the next one.
All right, great. I'm looking forward to it.
Fantastic. Thanks, Keith.
Okay. Thanks. Bye.
All right, bye.
Action Analytics.